Okay, so here we go with another example. It's about the cylinder of 200 kilogram beam is going to be suspended by a cable at its end as shown. If the man pushes on its other end, okay, now we're talking about suspended at the A, and this guy is pushing from the other end, but with a height of at this position at 30 Newton force. So this horizontal 13 Newton force determines what will be the initial acceleration of its mass center G, the beam's angular acceleration, and the tension at the cable AB. So we need to find its initial acceleration, and this can be the horizontal one, the beam's angular acceleration, and the tension in the cable AB. So we start now by putting the free body diagram for this example. Tension is upward at the point A. The weight is downward at the point G. And we have the horizontal force of 30 Newton at 1.25 meters below the center point. So that will be the main thing we're going to choose. We're going to do the kinetic diagram in the next step, and we're going to continue doing the solution as normal. So once again, we're going to have the three sets of the equations, and we're going to get the moment around the point G to be equal to the Ig alpha, and we're going to solve for the tension, for the Ag, for the alpha. The Ag, of course, should be horizontal acceleration. So we start with, once again, define the problem. The beam undergoes a general plane motion. Both point A and B, okay, are going to be, cannot be fixed axis through the points because the cable is soft. So the cable itself may swing. So define the free body diagram. We're going to have the weight going downward at G. We're going to have the tension going upward at the point A. And at the point B, we're going to have the force of 30. Now, for the kinetic diagram, we're going to have first a vertical force, which is going to be the M multiplied by the AGY. And we have horizontal force, which is going to be the mass multiplied by the AGX. Now, we still have the Ig, which is going to be Ig alpha, okay? And we're going to continue doing the solution for this part by knowing that the force is 30 Newton, the mass is 200 kilograms, the omega is 0 radian per second, and the unknown is going to be the tension, the Ag, and the alpha. So the three sets of the equation we're going to use are the normal one. Okay, we can do the moment around the point A, so we can use the value for the Ig of the cylinder, which is going to be the same one that we learned about earlier. You remember that one, over 12 multiplied by the mass multiplied by the L square. Okay, and this will be equal to the mass multiplied by the acceleration, plus the mass multiplied by the acceleration at the point G to the x direction multiplied by the distance from the G to A. So it seems that from this scenario, we can find the answer because now we know this is 30 Newton multiplied by 3.25. That's what we're going to have in the MA. Okay, in the free body diagram. The Ig can be calculated because we know the mass, we know the length. Okay, and what else do we have? That's it for the moment around the point A because the G doesn't have any force that causes the moment, except in the kinetic diagram, was going to be the mass multiplied by the AGX multiplied by that distance. And we have the Ig alpha, which is going to go once I get to the counterclockwise. Anyway, we can find two relations by finding the forces to the x-axis and the y-axis. In form there, we can start to do the calculation for the moments. It's up to you to which one you start first, because at the end, you're going to end up with the same result. So first, we're calculating the Ig value, and we have 1 divided by 12 multiplied by 200 multiplied by 4 square. And this will give me 266.7 kilogram cubic meters. Oh, sorry, that's square meters because we have the 4 square. Now we're coming to the forces to the x direction, and what we have in the x direction is going to be the 30, and in the in the kinetic diagram we're going to have the mass multiplied by the AGX. Now we can solve for the AGX. It's just simply 30 divided by 200, and this will be 0.15 meter per second square. Now we're going to the y direction. Is going to be equal to the weight, negative, plus the tension, positive. Is going to be equal to the mass multiplied by the acceleration to the y direction. Now, we don't know what the tension is, and we don't know what the AGY yet. So we're going to come with a relation between the t and the acceleration g to the y. Now we can find these results by solving the t value, then we can know what the AGY is. So we're going to go to the moment equation. So the moment in the free body diagram is the 30 multiplied by the distance of 3.25. On the kinetic diagram is going to be equal to the mass multiplied by the AGX multiplied by 2 meters. Okay, that's 2 meters. Plus the IG alpha. And we don't know what the alpha is. But the AGX is known, this force is known, so we can find the value for the alpha. So by solving this one, we can simply come to the conclusion that force multiplied by the DAC is equal to the IG multiplied by the alpha, mass multiplied by the AGX multiplied by this and RGA. Analyze the direction. This one will go to the counterclockwise. This one will go to the counterclockwise, and that one going to the counterclockwise. So all going to be positive. Putting these values in, and in this equation, the alpha is going to be the only unknown I have. Okay, we have the 2 alpha here. Actually, here we forgot to put, no need to actually do the alpha because we know the AGX. Okay, so now we solve for the alpha and find that the alpha is equal to 0.14. Now, at this stage, we don't know what the tension is. Anyway, we can find the value for the AGA or the AG to the y direction simply by using the relative acceleration equation between the point G and the point A. So we're going to apply this equation. The AG is equal to the AA plus the AG slash A. And we put all the parameters in. So we have here alpha multiplied by the K, alpha K multiplied by the distance from point G to the point A minus the omega square multiplied by the distance from G to A. Now, we're doing the G to A, that means from A to G is the distance. So it's going to go down by minus 2 meters in the y direction. So by solving this one, knowing that the omega is going to be square, so this side is going to go to 0. Okay, and we start to do the solution for that. Simplify it further. Okay, so it's going to be the AGXI plus the AGYJ is equal to the AAX plus the AAYJ plus the 2 alpha I. Now, of course, the 2 alpha I came from the K times the J is negative I multiplied by minus 2. So let's make it positive 2 alpha I. Now, if I get to solve for the I can find that the AGX, the AAX, and the 2 alpha I. If I get to solve for the Y, I have the AGY, and I have the AI. So by solving and finding relation, we can simply say that the AGY is going to be equal to the AAY, and this will be equal to the omega square of the A multiplied by the RA slash B. Okay, so we are going to choose this value. We know that the omega is equal to 0, so this will come back to 0. Now we just solve that the AG in the y direction is equal to 0. Now we're going to solve and put that in the equation 2. and we come to the conclusion that the tension is going to be equal to the weight. That's it. The problem has been solved. Okay, so that's it. All related to that the omega value is equal to 0, and this will solve the AGY for me. Okay, now we are going to have 30 questions to come. Actually, we're running in good timing, so I'm going to be able to give you another